Today we want to go over some of the indice rules. So we'll start by asking ourselves the question, what is an indice? Well, an indice, which we also call a power, that tells us how many times the larger number is to be multiplied by itself. This number or letter is known as the base. So 5 squared, or 5 to the power of 2, actually means 5 times 5, which gives us 25. And 5 cubed, which is 5 to the power of 3, actually means 5 times 5 times 5, which is 125. In the last example, a raised to the 4, or a to the 4th power, means a times a times a times a. When we give an answer in indices, the answer is said to be given in index notation. So, for example, 3 times 3 times 3 times 3, we would write as 3 to the power of 4. That's our answer in index notation. 5 times 5 in index notation is 5 squared. Note, we don't work it out, so we do not write 25. We leave our answer in index notation. X times x times x, well, this would be written as x cubed. And this one, 2 times 2 times 3 times 3 times 3. Well, here we would need to go 2 squared multiplied by 3 cubed. The first rule to remember is that anything to the power of naught is 1. It doesn't matter what the base is, the answer will be 1 if it's raised to 0. So 2 to the power of 0, guess what? Is 1. 5 to the power of 0, 1. X to the power of 0 is 1. A to the power of 0 is 1. So remember that one. Anything to the power of 0 is 1. The second rule, anything to the power of 1, the base does not change. So 4 to the power of 1 is just 4. 3 to the power of 1 is just 3. And a to the power of 1, it's just a. In this case, we're asked to do a calculation with two indices that have different bases. So it's important that we work each of the indices out independently before doing the calculation, in this case addition. So 6 squared, remember, means 6 times 6, and that's going to give us 36. And to that, we need to add 2 times 2 times 2, which is 8. 36 plus 8 is 44. And here's another example. The bases are different, so we'll work each side out independently before doing the calculation. So 4 times 4 times 4, that's our 4 cubed. 4 times 4 is 16, times 4 is 64. And we're going to need to multiply that by 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27. So 64 times 27, you can use your calculator to find out that equals 1,728. Here again we have another example. We are adding 3 indices with 3 different bases, so we're going to have to do each independently. The first is 4 squared, or 4 to the power of 2. That means 4 times 4, which gives us 16. And to this we're going to add 3 squared, or 3 to the power of 2, which is 3 times 3, and that gives us 9. And then to this we're going to have to add 5 times 5 times 5, which is 5 cubed, or 5 to the power of 3. That's 5 times 5 is 25, times 5 is 125. And now we can do our addition. 16 and 9 is 25, plus 125 gives us an answer of 150. And here's one more example. Our bases are different, 4 and 2. So 4 times 4 times 4, that's our 4 cubed, or 4 to the power of 3. Well, 4 times 4 is 16, times 4 is 64. And we're going to divide this by 2 cubed, or 2 to the power of 3, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 64 divided by 8 is 8. When multiplying indices together that have the same basis, here the base is 6, all we need to do is add the powers. So 6 cubed multiplied by 6 to the power of 4 is just 6 to the power of 3 plus 4. We add the powers. So that's going to leave us with 6 to the power of 7. And normally we leave our answer like this in index notation. And here are another two examples. The bases are the same, they're both 7. 7 to the power of 4 multiplied by 7 to the power of 5. Well, that's going to be 7 to the power of 4 plus our 5. 7 to the power of 9. And our last example, in this case we haven't got a number as the base, we have the letter D, but they're both D's, so it's okay, the same rule applies. D to the power of 6 multiplied by D to the power of 5 is D to the power of 6 plus 5. And so that's D to the power of 11. When dividing indices that have the same bases, we subtract the powers. But it's important to remember that we always subtract the one we're dividing by from the one we're dividing into. So 8 to the 5 divided by 8 to the 3 is the same as 8 to the 5 minus 3, which is 8 to the 2, or 8 squared. Here we have 14 raised to the 7th power divided by 14 raised to the 3rd power, and that becomes 14 raised to 7 minus 3, which is 14 raised to the 4th power. And again, we tend to leave our answer in index notation. In this example, we're still dividing indices, but this time it is written as a fraction. So, like any fraction, we divide the top by the bottom. So, 6 to the 4 divided by 6 to the 2 could be written 6 to the 4 minus 2 is 6 to the 2, or 6 squared. This next example is again written as a fraction, and we're using letters instead of numbers, but the same rule applies. So it's h squared divided by h to the power of 5, which will give us h to the 2 minus 5, or h to the minus 3. Remember to subtract the 5 from the 2 and not the other way around. Here we're asked to square a number inside brackets, but the number is already an indice, in this case 4 cubed. So what we do here is we just multiply the indices. So this can be rewritten 4 to the power of 3 times 2, which is 4 to the power of 6. And usually we would leave our answer like this in index notation. Here's another example. A to the power of 4, all raised to the power of 6. And again we just multiply the powers. So we get a to the power of 4 times 6, which is a to the power of 24.